Okay, integration of exponential functions. Now you know that the derivative of e to the x is e to the x, which means the integral of e to the x is e to the x, and if it's an indefinite integral, then you have to plus c. Likewise, you found out that when you're differentiating e to the ax, you have to multiply that by the derivative of ax, which is a. So that means when you're integrating e to the ax, instead of multiplying, you have to divide by a, or times by 1 on a. If you notice that the derivative of f of x is in front of e to the f of x, and you have to integrate that, then that'll simply become e to the f of x plus c, because you know if you were differentiating e to the f of x, you would get f dash x e to the f of x, which is what we have here. So let's look at some examples. First question, the integral of e to the 2x. So remember, the e part is going to stay exactly the same. If you were differentiating this, you would times it by 2. So integrating will divide by 2, and we'll plus c because it's indefinite. And remember, you can always check your answers by differentiating. So differentiate this, and you would have 2, and the 2's would cancel, and you get e to the 2x, which is what we started with. Alright, in number 2 here, we have a definite integral, e to the half x. So that is going to equal, we'll keep the e part exactly the same, e to the half x. The derivative of the power is half, so we have to divide by half, like that. And remember, when you divide by half, that's the same as timesing by 2, so that's 2e to the half x. And we're going to sub in our limits, 2 and 0, so we'll get 2e, 2 times half is 1, minus 2e, 0 times half is 0, so this becomes 2e minus, remember anything to the power of 0 is 1, so that's just 2e minus 2. Okay, find the primitive of x e to the x squared. So that means we're finding integral of x e to the x squared. Now you can almost see that x is almost the derivative of x squared. The derivative of x squared is 2x. So we can't really integrate it like it is, but if we put a 2 there and a half there, then they're the same thing. They're the same integral because half times 2 is 1. But now you can see that 2x is the derivative of e to the x squared. It's the derivative, of the power. So then you can say that that's equal to half e to the x squared plus c, because you can see if you were to differentiate this, it would be half times 2x e to the x squared, and the 2 and the half would cancel, and you just be left with x e to the x squared, which is what we started with. So always looking to see if you've got f dash x here, where f of x is that power, or if you've got something close. Okay, now because we are spinning around the x-axis in this question, that means the formula that we're going to use is v equals pi integral of y squared dx. Now y equals e to the x. So what does y squared equal? Well, squaring both sides, and you'll get e to the x all squared. And remember, powers are powers, your index laws, that's the same as e to the power of 2x. So we are, to find the volume, it's v times the power of y squared, remember now, is e to the power of 2x dx, and our limits are 1 and 2. So integrating that, we will have e to the 2x, and we'll divide by 2, and we will sub in our limits. So I'm just mentally checking, differentiating to check, bring the 2 down, e to the 2x, which is what we had. So subbing in, now we'll have subbing in 2, we'll get e to the 4 on 2 minus e to the 2 on 2, and I guess you could take out, you could leave it like that, or maybe you could leave it as pi on 2 e squared and e squared minus 1, and volume, so that's units cubed. But, you know, you could write that a couple of different ways. Okay. Question. Alright, sketch the region bounded by the curves y equals e to the 2x, y equals e to the negative x, and the line x equals 1. So, let's see what we have here. Oh, we have a nice line tool. Alright, so we have our x-axis. Oops. We get a vertical line. No, I'm just going to draw it. Alright, the curve e to the 2x is going to be like this. Y equals e to the 2x. It's the y-intercept there will be 1, because remember e to the power of 0. Anything to the power of 0 equals 1. The other graph we've got is y equals e to the negative x. Now, similarly on this graph, the y-intercept is going to be 1. But it'll be going this way. So that's y equals e to the negative x. And the line x equals 1 is going to be a vertical line. Maybe around here, we'll say. Sketch the region bounded by those three curves. So we are talking about this region in green there. If this region is rotated about the x-axis, find the exact volume formed. Okay, so the formula that we're going to use to find the volume between these two curves is v equal, and it's being spun around the x-axis, the integral of f of x squared minus, and you'll notice the colours I'm using here, g of x squared, where we've got the top curve minus the bottom curve. And the top curve you can see is our red curve, and the bottom curve you can see is our blue curve. So, and that's going to be the limits between 1 and 0. So let's just fill those into between 1 and 0. So, if y equals e to the 2x, then y squared would be e to the 2x all squared, which would be e to the 4x. And for this graph here, y equals e to the negative x all squared. We square both sides, that's e to the negative 2x. So going back to our volume formula, we have pi times the integral of f of x all squared. So that's e to the 4x minus g of x all squared is e to the negative 2x, and that's between 0 and 1. So integrating both of those, integrating e to the 4x is e to the 4x on 4, and integrating e to the negative 2x is e to the negative 2x. We have to divide by negative 2, and that is between 1 and 0. So let's sub in our values then. When x equals 1, you get e to the power of 4 on 4 plus e to the power of negative 2 on 2. And then we are going to minus, subbing in x equals 0. So e to the power of 0 is 1 plus, and then we have another e to the power of 0. And I'm going to close those brackets off, and then we also have a big set of, let's close off the square black brackets. And then the question says find the exact volume formed. So that means you want to leave your answer in terms of pi and in terms of e. So let's see if we can simplify this. We've got e to the power of 4 on 4 plus e to the power of negative 2. Remember your negative powers. That's like saying e to the positive 2 on the denominator. And then we have minus a quarter plus a half. A quarter plus a half is 3/4. So this will be minus 3/4. like that. And there we have an exact volume. We could make this all over the one denominator if we wanted to, but leaving your answer like that is perfectly fine. And then because it is volume, we'll say that's units cubed. Okay, in this next example here, I just need to make a slight change. That should be between the limits 0 and k. Okay, so let's integrate this function. The integral between 0 and k of 1 on e to the x is the same as the integral between 0 and k of e to the negative x dx. Okay, and if that equals e squared minus 1, we'll put that down. Let's integrate the left-hand side. So the integral of e to the negative x is e to the negative x divided by negative 1. And then we need to sub in our limits. And we'll just still say that equals e squared minus 1. When we sub in our limits, we get negative e to the negative 0 minus negative e to the minus k. And that equals e squared minus 1. So, negative e to the 0 is negative 1. And e to the negative k, oh, well, we can see what's happening here. Equals e to the squared minus 1. If we add 1 to both sides, then we get rid of those little minus 1s. And then you can see clearly that if both the bases are both equal to e, so that means the exponents of the powers are both equal. So k, or negative k, must equal 2. So that means k must equal negative 2. Okay, last question. Differentiate blah, hence integrate blah, blah. These are typical exam types of questions. So, part 1, let's differentiate e to the x squared. So, the derivative d dx of e to the x squared, we already did this in a previous question in this video. The derivative of the power x squared is 2x. And then we keep the e bit exactly the same. So we've got 2x e to the x squared is the derivative of e to the x squared. And you can see in part 2 here that we almost have to integrate the what we just differentiated. So if the derivative of e to the x is 2x e to the x squared, that means the integral of 2x e to the x squared must be e to the x squared. But we don't need to integrate 2x e to the x squared, we just have to integrate x e to the x squared. So we could, though, add a 2 here and a half here. And then we can integrate, because you know the integral of 2x e to the x squared is e to the x squared. So this integral is equal to half of e to the x squared between 1 and 0. And so then subbing in our limits, we've got e to the power of 1 squared minus e to the power of 0 squared, which is really just e minus 1. Half times e minus 1.